Sorry. If you can implement like a little bit more, it's always welcome. Do you want to implement more?
What should I do? Like, I should implement this model on your radar, or
maybe I want you to evaluate some accuracy. I think you are doing right.
but if I'm giving the one, if I'm on the basis of that, if I'm calculating the accuracy, it will be like either or that.
Yeah, so you have to do some average. You have to do the formal evaluation, like having a training set and test set.
Fine tuning.
No fine tuning. Just have a dedicated test set and test the accuracy of your model. The actual number. 60% is fine. Yeah, that's a good start. And then you can show baseline is this. So you need to evaluate in your special study.
I need to understand that to have a dedicated training set.
No, training set you don't need to touch,
Okay.
but you need to have a testing set and test your model inference.
Okay.
And see whether how many correct, how many wrong.
Okay.
And
So instead of just one passing one parameter, passing around 10, 20,
not 10, 20. I mean, for example, in Slate, how many testing samples?
1096.
Yeah, that much.
Oh,
Yeah.
so you want me to put the complete test?
Yes, and I want you to see if you use this way, how far are you from the state of the art, which you will be very far, 20%, right? Yeah, I want you to at least know that, oh, okay, if I use this way, I have 20% power. That's it for your special study.
If I do that,
that would be much better instead of just, okay.
I try for this.
You can do it. Question answeringอยู่ที่ว่า open ended possibility. If it's a closed ended, it's a classification. If it's open ended, it's a definition. Because ก็คือมันเป็นหลักการที่เราจะดูว่าใช้ในคือถ้าเป็นมาตรฐานด้วยที่ไม่ได้บอกได้แต่ว่าตรวจว่ามันเรียกว่าที่ยิงแต่ที่แปลงนั่นก็เลยแล้วแต่ว่าที่เขายังไงก็ต้องเดี๋ยวก็คือรู้ไหมว่าตอนนี้ถ้าเราคิดเป็นข้อมูลมาแล้วมันก็จะเป็นสิ่งที่จะเกิดขึ้นแต่เราจะไม่มันจะได้รู้ว่าหรือว่าเป็นที่หลายแต่ว่าเป็นไงตัวอะไรแต่ละเรื่องหรือในทั้งคู่ All right, so let's start our class, and good morning, everyone. I think students will be coming very soon. So, are you guys done with your midterm exam? No? Last one? Done. No, you don't have. Last one. Okay, great. So yeah, hopefully you guys are done with the midterm exam, and good luck. Hopefully you guys score very well on all your midterm exam. So today we are working on a very important topic, which is question answering. And question answering is basically encompass also ChatGPT, right? In which if anyone work with ChatGPT, you can also ask questions, right? And then it can also give you answers, right? Or any question answering system is basically all encompassed in this area called question answering. So where are we now? We are right here, right? So we are in
today, what we're gonna do is something called close-ended question answering. But there's another one that you can also study, which is open-ended question answering, right? Which is probably Wednesday. So again, it may seem that we teach you a lot, but if you actually slow down a little bit and review everything I taught you, I did not really teach you a lot, right? But it just seemed that there's so many things you never heard of, so it feels a lot, but actually it's very little, right? So once again, let me, because today I think we have some time while waiting for students to pop in. So you must know like the basic tokenization methods, which is by-pair encoding, which is used in GPT, word piece, which is used in BERT, right, and unigram, which is probably used in T5, if I'm not wrong, right? So that one you need to do. You don't really need to know how to do them by hand, but you need to know them by concepts, right? Because otherwise you cannot do anything if you don't understand their concepts, right? You need to know word to vec because it's very basic. You need to know globe. You need to know definitely bird. Based on A5, I think you are very familiar with sentence bird, right? And because you do sentence bird, you also understand bird, right? If I'm not wrong, right? So hopefully through that A5, we hope that you understand bird by heart. And definitely one more thing that we actually want you to understand is SimCSE, which is about contrastive learning. I'm planning to teach this maybe slip into one of our courses, one of our classes, because contrastive learning is a very, very important topic. And fast text is basically word to vec in character form. And Elmo is basically LSTM using the LSTM hidden states to transfer to all the NLP tasks. So this may look very difficult, but basically Elmo is the pre-model before we have something called BERT, right? So Elmo is, the idea is basically saying that, hey, we don't need embeddings. We just train Elmo, basically LSTM, many tasks, and finally we extract the hidden states, right? Then we can basically transfer to every other task, right? So Elmo is probably the one that you should think about. It's actually not BERT that is the father of. All right, so that is also something you need to know. And this is the whole list you need to know, right? Supervised learning. And last time I'm very afraid because I asked you guys a lot of questions and no one seems to be able to answer me. It's either two things. You guys are shy or you guys are shocked with, you never heard of this question. Which one? You guys are shy? Or you guys are not familiar with the question I throw you? Probably both, right? Yeah. So yeah, please make sure that you understand all the essence, right? I would try to maybe review one more time, and then I would try to throw some question to you, okay? You also, so these are the architectures. You need to code from scratch. You need to know how to code from scratch, right? And you also need to know the concepts and also transformers. In the entire classes, if you understand this, in the entire classes, if you understand this, you are actually already enough. Because all the things I teach you use all these architectures. right? But the problem is you don't truly understand by heart, right? So how do you truly understand by heart? Huh? Yes, practice, right? That is the only way. Similar to mathematics. No one is good at mathematics because of the teacher. No. Mathematics is good because you practice, right? And with the proper guidance from the teacher, right? Similar to NLP, machine learning, deep learning, everything is all about you practice. So if you actually understand this part, you already understand 90% of my lectures. The next part you need to understand is what is self-supervised learning, right? BERT, GPT, BART, when do we use which one? This one you need to know. You also need to know if we have supervised learning, why do we need to have self-supervised learning? You also need to know that, okay, let me maybe wait a second. Then we have something called transfer learning, right? Which is taking the pre-trained model and then fine-tune. But you also need to know that fine-tuning is nothing but supervised learning, correct? Because in fine-tuning, you always have X and Y, correct? So you always need to understand the essence, like essence. Even Achaki did not tell you, you always need to capture the essence, right? That fine-tuning the pre-trained model is actually a supervised learning, right? So you should not question like, should I use supervised learning or self-supervised learning? No, right? Because you can self-supervised learning, create a pre-trained model, then do supervised learning, such as fine-tuning, to train the model, right? But you also need to understand that fine-tuning is very bad because fine-tuning is task-specific. Fine-tuning is task-specific. What does that mean? Yes. So it's particular for specific tasks, right? If I want to fine-tune for sentiment analysis, I need to get the data set of sentiment analysis, right? When I want to fine-tune for maybe natural language inference, I need to get that data set and fine-tune, right? Is it good? It's not good, right? Because if I have 10 tasks, I need to fine-tune 10 times. That is the biggest problem you need to know. If you have 10 tasks, you need to fine-tune 10 times. When I say you need to know, is because you now understand. But suddenly, if you go to the interview, you go to SCB or KBTG, they ask you what is the problem fine-tuning. I just change the question a little bit. You guys cannot answer. Trust me, because the angle changed a little bit, right? So now I ask you, what is the problem of fine-tuning? It takes a lot of time, right? For each task, you fine-tune one time, right? So, Chucky, you may say, oh, fine-tuning is faster than pre-training. Yes, but fine-tuning, you still also cannot do because we don't have the GPU, right? Now, how many ways we can fix that? So many ways, okay? I will write down. And you need to understand that all of this is to fix this problem. 1, instruction tuning. 2, prompt-based learning. 3, augmented reality. Not augmented reality, augmented retrieval. 4, pruning. 5, distillation. 6, quantization. 7, PEFT. All of this is to fix this problem. You need to know this. How instruction tuning fix it? You don't need to have sentiment analysis 1 XY for another data set, another XY, no need. Combine all of them into the same format. This is called instruction tuning. You don't need to have so many X and Y. Do you guys understand? You guys don't look at your computer too much. Listen to me. It's not in the lecture. It's hidden in the lecture, right? But I talk from my head. Yeah. So you guys can understand. If you have 10 tasks, how many XY format you have? I'm talking about format. 10 format, right? So that means you need to do 10 times, right? The question is, can I put all of them into the same format so I train only one time? Can I? How? Instruction tuning, yes. That's it. This is the key. So if I just take the sentiment analysis and then I just add something like sentiment, right? I just add maybe just in front of X and then the sentence and then the Y is positive, right? I also can take the machine translation and then I can add something like MT. Please, or maybe I can choose, please translate this sentence. And then the Y is the English or French or whatever. I can also take some tasks like summarize it. Please summarize for me this sentence. And then the answer is this. By doing this, I put all the data in one format. And I train only one time. I create one model that understands all 10 tasks. Do you understand? This is the key. This is the key. Yes. You may have question like, is there many ways to write this thing in front? There's so many ways. You can write, please translate this sentence from Thai to French. Translate this sentence to Thai to French. Translate Thai to French, right? It does not matter, right? It's just that as long as you have the keyword translate, the computer know that whenever there's a translate, this sentence will become this sentence. They know, right? So you can see that instruction tuning partially fix this task that is 10 tasks you need to do train 10 times, right? Instead, combine all of them into one task, one format. This is instruction tuning. And this is what you get from ChatGPT. Without this way, you cannot have ChatGPT. Without this way, you cannot have ChatGPT, right? Because by doing this way, you can get one model that knows everything. Now, number 2 is prompt-based learning, right? Prompt-based learning is nothing. By the way, if in the interview, if I ask you in prompt-based learning, do we fine-tune? Who say yes? Who say no? Who say I don't know? Hey, he teach that class, right? Okay, so maybe I ask the TA, in prompt-based learning, do you fine-tune? No. You don't fine-tune, okay? If you guys go to interview, you cannot answer this question, will the company get you? Can you tell them, I studied this course only 3 months. I have so many exams. That's why I cannot answer you. Can you say this? They don't care about you. So now I ask you, in prompt-based learning, do you fine-tune? Then what do? You just prompt, right? You just, I want this, and then it will give you, right? Then maybe the interview asks you, what is 0 shot? What is 1 shot? What is few shot? What is that? What is 0 shot? Like examples, right? In 0 shot, you don't give example. You just ask, please translate this sentence, right? In 1 shot, you give one example. One example. I go eat rice. Equal to ผมไปกินข้าว Then I go eat sushi. Equal to what? This is 1 shot learning. You give one example. Do you understand? But there are so many shots, right? They can be 2 shot, 3 shot, 4 shot, right? Everything is called few shot. Okay. not many shots, just few shots. Now, I will skip number 3 because I never teach you 3 yet, okay? But 3 is something called RAG, but I will not teach you this one yet. It's Wednesday, probably. Pruning. You need to understand pruning, right? But what is the biggest problem of pruning? Oh, first of all, what is pruning? Anyone can answer me. There are 2 ways. One is you just set some number, some weight to 0. This is called, there's actually not something called, it's basically fine grain pruning. Fine grain pruning. Basically, you set some weight to 0, some number, okay? Fine grain is useless because the weight matrix, the size is still the same. By the way, do you guys understand me? Who understand when I talk like this? Okay, 1. Okay, 2. So okay, 2 people. Can I have try to have 5? So let's say I have a weight matrix. First of all, do you guys know what is a weight matrix? Everyone know what is a weight matrix, right? You don't, by the way, you don't need to afraid of me, okay? What is a weight matrix? You guys understand, right? Okay. When I prune, I just multiply with a mass. Where does this mass come from? I did not teach you, right? But there are many ways, right? You can randomly create this, or you can create based on the lowest weight, okay? If it's a lowest weight, this probably these 3 guys are the lowest weight, right? Then this will be 1, 1, 1. Everything is 0, all right? So they are random or magnitude. Then the final weight is what? 1, 2, 0, 0, 0, 6, 7, 8, 9, 0, 0. Do you guys understand how did I get this? Who understand me, please raise your hand so that I can be a little bit relieved. You understand what I'm talking about? Okay, good. Right? So now, this is pruning, right? What's the problem? The weight, the size of the weight matrix is the same, right? If the size of the weight matrix is the same, what's the problem? The computation time is the same. So you did not do anything. Understood? You did not basically do anything. Pruning, no use. Like this is no use. Okay? Pruning is no use. Yeah. So what is another way? By the way, this is called fine grain pruning, right? Right. And of course, if you can imagine, there's another way called coarse grain pruning, right? And the idea is very simple. Just cut layer. Just cut layer. Delete the layer. So for example, if you have this weight, you just delete this one. Correct. But this kind of pruning is not easy because of what? Information. Because your input does not cannot accept this shape, right? When your weight matrix shape change, the biggest problem is your input cannot dot product with this guy, right? Then there's a limitation on which part you can prune like this. Understood? You can only prune like this when your input is okay. Or you are willing to also change your input shape, right? So these are the things you need to consider, right? Oh, definitely there's an information loss, right? Definitely, yep. But now, to answer Deepali a little bit question, is there any information loss? And the answer is definitely yes, because you cut something. But from what we learned, there are many useless numbers. There are many useless numbers, right? So we definitely can prune at certain extent. So that is the essence of pruning. We also learned about distillation, right? Distillation have two models, teacher and student. Usually, which one is smaller? Student, yes. Why do we need to have teacher and student? Why we just don't use teacher? Because teacher is big, right? So how do we create a student that is as good as the teacher? Very good. Very good. Basically, create a student that is much smaller. Like you are the student, right? I'm the teacher. You guys are smaller than me. But I say yes, you say yes. Okay, finish. You copy my output. Then you will be as smart as me. This is the key concept of distillation. But the idea is you don't need to only copy my output. You can copy how I walk, how I eat, how I live my life. The more you copy me, the more you become like me. So that is the idea of you can copy the hidden state, you can copy the attention, you can copy the value, you can copy everything, right? The more you copy, the better. Not only the output. This is the essence I teach you. Quantization is a very like, okay, let's say that normally all the model use 32-bit. 32. By the way, who needs a computer science? When I say 32-bit, do you know what it means? Anyone don't understand when I say 32-bit mean what? Anyone understand when I say what does 32-bit means? Okay, one guy. 32-bit. So you may question like, Chucky, how do I know what is 32-bit? You guys need to question, right? Question. And maybe ask ChatGPT, then you get the answer. But here is my idea. Chucky is eating sushi, right? All right. In a 32-bit system, C is represented by how many numbers? 32 numbers of 0 and 1. So I don't know what is C, okay? But in ASCII number, I am not sure. This is a capital number, right? So I'm not sure what is that number. 67? Okay. So I'm not sure what is 67, right? But I have many zeros here. How many? I need 32 of them, all right? And then in the end, near 32, I need to have number 67, right? What is 67? 1 1 something, right? Yeah, 1 1 0 1 1 something 1. Okay, let's say this number means 67. Okay, yeah, this is 32-bit. This when I say 32-bit. Then you may say, why there's so many zero in front? For who? There are so many characters in the world, right? Maybe if I write a Chinese like this, maybe this guy need to use numbers in front. Maybe I use an emoji. This guy may use numbers in the front, right? There are so many characters to represent. So that's why this guy used 32-bit system. Can I use 16-bit? There is such system too. Can I use 8-bit? Also. Is there 4-bit? Also. 2-bit? 2-bit is a little challenging, but I don't know. Yeah. So what is the idea of quantization? In a 32-bit system, you use the full 32-bit. Okay. But quantization say just change to 16-bit. Then you can save the performance, right? You can also change to 8-bit. You can also save performance, right? You can change to 4-bit. But the question is, the more you do like this, the more there's problem with information loss, right? Then what do you do? Yeah, those are the contribution of all those papers that you learn from here. Yes. How do you actually convert 32-bit to 16-bit? What is the challenge? From 32-bit to 8-bit, what are the challenge, right? In Q Laura, he teach you, right? How many bit they use? Maybe I ask him. Actually, I don't know. Gun in Q Laura, 4. Okay, 4-bit. They use 4-bit. 4-bit. Today, someone told me people are doing something called 1.8-bit. I don't know how they do that. Yes, but some people do like this. Yes, and I'm not sure how they do this, why there's a decimal, but I just want to tell you that in 2024? Yeah, 2024, there's someone proposing 1.8-bit, which we don't even understand. I did not read the paper, by the way. So many papers I need to read, right? But someone proposed this. But end of the story, this is a quantization. Lastly, we have PEF. What is the key thing about PEF? What is key essence about PEF? Fine tuning take a lot of time, right? How do you only fine tune only a small number of parameters? This is the key. Okay, so let me write down. So normally, what do? You take a pre-trained model and you do something called fully fine-tuned, right? Fully fine-tuned means update all parameters. Correct? This is truly bad, right? Because even you guys won't be able to fully fine-tune ChatGPT, Llama. You guys cannot, right? Your GPU, no. With my GPU also cannot, right? So the idea is, how do you freeze most of them? Freeze like 90% of them, and only train maybe, okay, this is a rough number, okay? Rough number, 90% is not exact number, and only train maybe less than 10% of the parameters. And gain same performance, right? This is what he teach you. Do you guys understand? So you guys must always use this technique, like always. There's no way you can escape this technique. First is adapter. What is adapter? You freeze everything, but add one linear layer in between feed forward. That's it. And only train that layer. It works well. But what is the problem of adapter? You change the architecture, right? Changing the architecture reduce the computational time. You listen carefully. It's not in the lecture, but it's in the paper. If you read the paper, you will be smart like me. But if you don't read the paper, I summarize for you. Adapter reduce the computation time. Prompt tuning is you add only in the prompt, right? Two embeddings. What is the problem? He told you already. What is the problem of prompt tuning? You need, because you only add a little bit in the prompt, right? And you freeze the whole model. You only train this two small portion of the embedding you add to the prompt, right? You need a very, very big model and a lot of training data to train this small guy. Capture that? Prefix tuning is good because you add in every layer, right? Extra, 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 right? But also take a lot of time. Because you do like this, it takes a lot of time. Lastly, do you guys understand LoRa? LoRa. Who understand the essence of LoRa? Raise your hand. Who understand a little bit? Okay, raise your hand. Okay. If anything else, you also need to understand LoRa because everyone is using LoRa. If you don't understand LoRa, then you cannot do anything, right? So let's say I have a 1000 by 1000 weight matrix, okay? All right. Yeah, okay. And if I fully fine tune this, how many parameters I need to update? 1 million parameters, right? How do I do that? Simple. Firstly, I create two more matrix. One is 1000 by 2, and another one is 2 by 1000. I only have two now. You freeze this one. You freeze this one. You don't, when you train the model, you don't train this guy, okay? But you train only this guy. But how do you let the model understand the relationship between this guy and this guy? You plus them, okay? You let this guy always add with this guy. Oh, Chucky, how they can add? This guy is different. Oh, they are the same shape. This together will be 1000 by 1000 anyway, right? Right? And you only train this guy. When I mean only train this guy means you forward pass, but because this guy is frozen, this weight will never change, right? But you only let this number change. Then you let this guy interact with this guy, right? For any task. Yep. So what is the meaning? The intuition is this guy is like pre-trained knowledge. It knows everything, right? But this is like extra knowledge, just extra to do that task. Understood? This is the extra knowledge to do that task. This is the pre-trained knowledge that you learn from the whole world, right? But you add only an extra knowledge to do that task well. This is the LoRa, and you must all understand this. So this is the story of NLP currently. If you listen from me from 9 o'clock to now, and you understand every single sentence I said, you actually understand a lot already in NLP, right? Aside from coding. Of course, you guys did not code, so you don't fully understand, but you already understand the concept. Great. Any questions so far on the whole picture? There are still a little bit I did not teach you, but wait a minute, okay? Anyone has any question on the story of NLP? Great. So of course, coding is another matter, but you need to practice. By the way, what is this lecture about? Question answering, okay. Just so what, I'm not sure you should cut my 9 o'clock to here. Otherwise, the YouTubers will feel like, oh my goodness, I'm talking nonsense again. By the way, is the review okay? Good? Okay? Okay. Okay, intro. Question answering. Question answering is super simple. Like, you guys understand what is question answering, right? I ask you a question, you give me answers, right? But actually, if we try to think about more, there are different categories. So let us classify first to understand question answering. First, reading comprehension. In this kind of problem, I give you a paragraph, I give you a question, and you give me answer. You guys remember this in your elementary school, right? Your teacher give you a paragraph, you read and answer, right? This is reading comprehension. Today we will learn this reading comprehension. Second is open domain question answering. You don't give anything. I just ask you. Russia. What is the color of monkey in South Africa? Brown. Okay, she said brown, right? But so in this kind of question, you have database. You have a question. Database is basically Russia head, right? The brain, his brain, her brain. Closed book. Basically, you don't have anything. You don't have database, but if you ask. So let's say that I don't allow you to access all your knowledge in the past, okay? I ask you, who made sushi? What color is sushi? What color is banana? Okay, let's say. Orange, okay, right? So, but I'm not sure how I explain this. Basically, in closed book, you don't have database. You don't have any information, right? It's purely from the model. It's purely from the model, okay? So let me make it very clear. I hope I'm clear on this. So open means open question answering means you have a question, right, to you, and you can also look up some database, and then you answer, right? And where does this come from? It can come from your PDF, it can come from your Excel, it can come from your SQL, okay? This is called open-ended, open domain question answering, right? But in closed, is completely rely on your model to answer. Your model don't have any access to any database, okay? So eventually closed book is obviously the most difficult because it had no access to closed book. But actually, currently the most famous way to do QA in the practical world, let you guys guess, in the real world industry, in which we have so many clients talking to me, say, I want a chatbot, I want a question answering system. Which three of this is the most practical? Open domain. It does not, if they have PDF, they have Excel, right? If we can also use that together with our model, this can create a very, very good system. And actually, I can give you the name. A very, very good technique is called retrieval augmented generation. And the name is a little bit like, but retrieval, basically retrieval from the database. Augment means you augment so that you can generate the answer. Yeah, right. So, but today I don't teach this one. This is Wednesday, okay? But today I teach you reading comprehension. There's one more that I wish I can teach you. If I have time, I will teach you. It's called visual QA. Okay. So what is a visual QA? This is a very, very interesting area that I'm also researching. Given an image, I ask you a question. Okay. So let's say this is the image. Okay. Okay. This is the image. What language is this image written? English. Okay. Human can answer, but do you think AI can answer? Of course, this is a very simple question, English, right? You just scan and it can answer, right? But if I have many, like very complicated pictures, maybe AI cannot answer, right? So this is a very, very interesting area of research, yeah. But I will not teach you today. I will teach you when I teach multimodal learning. Combine what? LLM and visual, yeah, together. Then this is a very exciting research. Yep. Okay, so today we only do reading comprehension and then we all go home, okay? How about we have a break? I think you guys take a lot of knowledge already. Okay, how about we have a break for maybe 5 minutes, all right? Refresh yourself and then we can discuss about this, okay? Yeah. All right, so let's start our session. All right, reading comprehension. Hopefully you guys are refreshed. All right, I got to rest my. I think I'm coughing less. Yeah. Reading comprehension. So this is the context of the reading comprehension. You have a paragraphs, you have a question, and you have an answer. Okay, human can do this very well. So why we care about this problem? Because a lot of problem in NLP related to this problem. For example, if we want to ask, for example, in the area of information extraction, I have a question. Where did Barack Obama graduate from? I have a passage. I want to be able to extract the information, right? So it's related to this area called information extraction. It's also related to an area called semantic role labeling, right? So you may ask, what is SRL? SRL is basically a subtask in NLP, which concerns with understanding the semantic of each of the words. This is called semantic role labeling. For example, if I want to understand what does finish mean, I can ask many questions. Which of these questions tell us about this word called finish? I also want to know this word called beating. I can also frame a lot of questions to better understand what does beating mean, right? So there are two things here. Semantic role labeling is basically understanding what each word is about, the semantic meaning of each word. And actually reading comprehension can actually help us understand this task better. So this is why do we need to understand this problem. Now, what is the famous data set that concern about this task? Why this task is so popular? It's because it's by Stanford. Stanford, yes. And the data set is usually called SQUAD. SQUAD means it's a team, right? But actually it's abbreviations of this data set. It's by Stanford in 2016. And nowadays, I think there's a SQUAD 2 and SQUAD 3, if I'm not wrong. Maybe SQUAD 2, but not sure 3. So there are 100K of triples. Triples of what? Triples of passage, question, answer. Triples. All of these are from Wikipedia. Where does the questions come from? Questions are made by human in Amazon Mechanical Turk. Each of the answer is only the answer in this data set. The answer must be a segment of the passage. Must be. So it's purely extraction. So I say again, when we ask the human to give the answer must be a segment in the passage. Must be. So it's a purely extractive. So this is the example. How do we evaluate this data set? First is exact match. Second is a F1 score. For the validation, sorry, some people use development, but development same as validation set. Okay. For the validation and testing set, there are 3 golden answers are provided. Why 3 answers? Because the guy who made this data set say that some answer may be a little bit different, right? So let's say there are 3 golden answers. Then how do we calculate the score? The score is usually the maximum of the scores. Okay. And finally, if you want to know what are the human performance, even human can only get 82.3 and F1 of 91.2. This is human being, right? To understand how do we calculate, actually I prepared an example, and this is a good practice for you or those who like NLP. Let's say no one like NLP because once I teach like this, you don't like NLP, but is for those who want to do NLP, let's say, what did Tesla do in December? The golden answer is 3 answers, right? Left grass. By the way, grass is a location in Germany or Switzerland? Switzerland, okay? Let's say Switzerland, okay? YouTubers, if I'm wrong, don't hit me, okay? And the second answer is also left grass, okay? By the way, this is one human being. This is another human being, okay? The third human being give this answer, left grass and severe all relations with this family, okay? These are the 3 answers, okay? By the way, for those who don't know what is Tesla, Tesla is not the car, okay? Tesla is a person, okay? So now, let's say your model, whatever model, predict left grass and severe, okay? What is the score? How to calculate the score? Exact match is simple. This guy is not matched with the first one, 0. This guy is not matched with the second, 0. This guy is not matched with the third one, 0. Take the maximum is 0. Okay? Now, how do you calculate F1? You need to know how to first calculate precision and recall. Okay? So firstly, let us do recall. And YouTubers won't see when I write on this whiteboard, right? So let me try to write in this minimal space, okay? Recall, right? Let's say the first example. Let's say I want to take this guy, okay? Okay, for the recall, right? So what is recall? Recall is number of overlapping words in both of them, 2 words, right? Correct? There are 2 words that overlap, divided by total of words in ground truth 2. Okay, and precision is number of overlapping words divided by total number of words in prediction, which is 4. Okay, so for those who want to understand what is the intuition, recall is basically whether you got all the things in the ground truth. This is the meaning of recall. Precision means you must be precise in how you answer. If you answer not precise, many words in your prediction that is not correct, you are not being precise. Understood? So this is the intuition of these 2 1. I will say again because some of you are writing. Recall is you must answer everything that is inside the ground truth. This is the meaning of recall. That's why it's divided by total number of in ground truth. Precision means you must answer correctly and also precisely. That means your prediction should not have so many words. It should exactly match, right? That's why it's divided by the words in the prediction. Okay, I say 2 times already, okay? Okay, anyone has any question? No, nah? Okay, if you don't understand, you just read this equation many times, you understand. Okay. Now, what is the F1? F1 is equal to 2 times recall times precision divided by recall plus precision, all right? Which is equal to 2 times, this is 1 times 1/2 divided by 1 plus 1/2, right? Correct? And if you guys punch the numbers, trust me, is 0.67 and hence this number. And you do this for the second guy too, and the third guy too. You will get all the answers. You take the maximum. This is the answer. All right. So you guys must be very familiar with how do you do recall and precision, right? Because it's used in also in in blue, in rouge. They all use very similar way. The way I teach you just now, okay? But there's many things like one gram, 2 gram, 3 gram, etc. Right? And I will not teach you that all of them, okay? But you understand the essence is important. All right. All right. So now you understand the data set and how do we evaluate. Let us form the problem, right? So the input is let's give in the input, and this is the passage, right? And there's an n tokens, and you got the questions, and there's m tokens, right? Each of them are in the library. The passage is around 100, and the question is around 50. Now, in this problem, the answer must come from the passage, right? The answer must come from the passage. So the output should be, you should give me two answers. Where does this start? Where does the answer start? And where does the answer end? This is the two number you need to keep in this problem. Do you understand? Yes. So for example, if the answer start from 47 and end at 49, then that you give me these two numbers. And if both numbers are the same, then that you get full mark. Okay. This is the the problem statement of squad. Now, how do we build this model? Namely, our esteem attention is probably the most popular for this one. And you can see a lot of them is like 2015 to 2017, right? And today I will teach you the one that is like probably the most interesting and probably the most talk of the town, right? Which is by that. But I have to warn you that nowadays, like you guys already know, no one use LSTM, right? Everyone use this, right? Oh, by the way, if I use pre-trained model, good question. In reading comprehension, this is the problem, right? Which architecture, if I want to use pre-trained model, which architecture should I use? Encoder, decoder, encoder, decoder. Which architecture should I use? You know that this question is very relevant, right? Because in a company, maybe you go to a company, your boss say, I don't know NLP, okay? I don't know NLP. I have this problem, okay? And this problem look like this. You please go download pre-trained model and use it. Your boss won't tell you even download pre-trained model means what. There are so many pre-trained model, right? And so many architecture, namely 3. Then it's your job to know which pre-trained architecture to use. Now you tell me which one. If you cannot answer this very well, then you cannot work in industry very well, right? Don't worry, because you're still with me, right? So I will tell you, but eventually you need to build up this skill. Do you guys understand? You can see that I always talk about this guy because there is this problem. When you go to a company, your company, I want to ask you, your company boss, will he tell you, Rachia, I got this test now. Please go download this model and train like this and do like this and do like this, and you give me this. Will your boss tell you like this? There's no such boss in the world. If he tell you like this, he just do it for you, right? He pay you to do the job for him. So he just say very short, I got this problem. Only 2 lines. You go download pre-trained model and do it. You need so much knowledge, right? You need to understand this point. Now I want to ask you, which one to use? And definitely, we can do some reasoning together, right? I don't want this to be too high pressure, right? And let's say I get a pre-trained model bird, right? Can I do this? Oh, wait a minute. In bird, I only get one input, right? For your information, in bird, you just put input and you get output, right? Right, in bird. Oh, There are two input. Can I use? You should not say no yet, right? Because Professor Chucky teach you, you can always concatenate, right? Then you can do C concatenate with Q, right? Right, concatenate with Q. And then hopefully you get the answer, right? How do I get the answer if I use pre-trained model BERT? Oh, I just delete this one and I add two linear layer, right? Two linear layer, and you will give me the start and the end, right? Then I can get the BERT. I freeze this one. I add two layer in front, and then I hopefully get start and end. You need to think like this. Then BERT can do, right? Actually, later on, a lot of people use BERT, okay? Can I use decoder? Can I use decoder? Decoder means GPT, right? Correct? GPT. So this class will end very quickly. You see, this is my problem, right? There are so many knowledge, right, to be transferred to you. GPT. So what is GPT? GPT is something like Chucky is, and then GPT will give you flying, right? Right? Or maybe, please do this, right? And then GPT will give you right? It's basically next token generation, right? Then how do you do GPT? Maybe I can do like this. I tell GPT, I can tell GPT like this, right? This is C, this is the passage, right? And put the text, whole text, right? And this is the question. What's the answer, right? What's the answer? Then GPT, GPT will give you next token generation, right? But we want start and end, right? We want start and end. So how do we map next token to what? To two numbers, right? How do we do that? Remember I teach you what? A paper from GPT-1. Remember? I can do like this. I can add two. This is the sentence, right? I don't only send these two sentences. I also send two token, like some random token. Maybe here and here, here too. Okay, maybe just random token. Right? So my sentence is very long, right? And when I send to GPT, actually GPT will give me the output same shape as this guy, right? This guy will predict something, this guy will predict something, this guy will predict something, right? Because this guy is a next token generation. This is what GPT inside do. Then I just take whatever this guy predict, that is the answer. Whatever this guy do, that is the answer, right? And then I fine tune it. So this, so once you think like this, which one will you use, GPT or BERT? If I were you, I would use BERT because I don't need to change a lot, right? I just concat CQ for BERT and add two linear layers, so easy. This one I need to add two tokens, and GPT is also very big, right? So I will use BERT. This is the way I would think. Now, encoder decoder. Do you think we can use encoder decoder? Let's say BART, right? What do you guys think? Do you think we can use encoder decoder? We can, right? We can. So we can. So in an encoder decoder, Actually, I think I should not draw like this, right? Encoder looks like this. You have some input here, right? And in decoder, you also have some input here, right? All right. Now you need to answer yourself. Oh, if I download BART, because BART is so nice, it's in the Huggingface. I got this far. Can I do this test my boss tell me? Oh, wait a minute. Encoder, decoder look like this, right? And I want this output to be, oh, Chucky, maybe I can also add two, because this is also decoder like GPT, right? Then I just add two token here, right? In the input to decoder. Oh, but wait a minute. I have one question. What is the input to the encoder? What is the input to the decoder? Oh, I have C and Q. Oh no. C go here or Q go here or Q go here and C go here? Yep, right. So I think there's um, a way to think like this, right? So encoder, the purpose of encoder is to try to understand something, right? Right. And you want to understand the passage, right? So you should send the C here, right? And decoder is basically some input that helps you understand what you want to answer from this C, right? Then you should put the Q here. Yep. By the way, how do Chucky very confident that this is this way? Because I read many papers and they all do like this. And you may say, can we put Q and C? I never try, and I will never close the door, right? You should not trust what I say. Deep learning is there's so many ways you can do it, right? The same thing. Yep. So in conclusion, in this problem, which way we can do? All way, right? But if I were you, I would use BERT because BERT no need to add any token, right? It just works. I just add two linearly. Yep. Okay, great. That is a long story short. That is the like industry practice. Now, how do we actually do this task? I will skip you from this slide, but the key idea is we don't need decoder. We don't need decoder because we only want the start and end, right? We don't need to output any token, right? We want to say the answer is 55 to 58, right? We only want two numbers, right? So decoder is no need. We don't really need decoder. Yep. We only need two classifiers. When I say classifier, it's nothing but linear layers. Plus softmax. Okay. Today class is will be a little bit delay, right? But I will try to make everything clear and also, okay. So how this BiDAF papers do, all right, is again in ICLR 2017. So ICLR is like, again, a top conference. So how do we do? First, you send the context, which is the passage. You send character embed and also word embed. Concat them together, send to the LS team. You get H. All right. For the question, you get the character embedding and also the word embedding, concat them together, send to LS team. You get U. Okay. So far, so good, right? This part finished. This part finished, okay? Now they send in, they need to understand the attention between the passage and the U, right? Between the passage and the question, they use something called query to context and query to query, okay? Context to query, which I will explain it in two slides, okay? I will not explain here yet. You will get some output called G. Okay. From the query to context, and the green arrow is from context to query. And if I'm not wrong, the gray arrow is the original H and U. Okay. So there are three colors. The gray is from the original H and U. The green is from context to query, and the orange is from the query to context. Okay. And then finally, this go into the LSTM, and then two linear layers. Right? Start and end. Okay? So very, very like high level. So probably the question is, what is query to context and context to query? How to do the attention? And actually, it's not so difficult. But before anything else, anyone has any question on this high level depiction of this model? If I give you an exam on this guy, like, hey, please code this. What do you guys think? Russia say easy, yeah, probably. No, I don't think this will be easy. It will probably take me 20 to 30 hours. Yeah, probably this part. No, I don't think that much. We already know attention, maybe 15 hours. Should be okay. Okay, so now, firstly, I have the passage. Let's say the passage is Chucky was born at Hong Kong, right? And I have the H, right? The H is from the LSTM. And let's say the size is 2, okay? To make a life easy. Actually, it's 300, okay? I make it 2. Okay, so far so good? And also, I also have the question, U1, U2, U1 to UJ is from the LSTM. And this, please take note the color, okay? Anyone color blinded yet? Okay, I should not ask, but if you have color blind, you let me know, okay? But it's the same. It's not the same, the color matters, okay? Then you multiply them. This guy multiply with this guy, element wise, okay? Element wise, you get 2. Okay, this is not dot product. If dot product, how many numbers you get? If you dot product, only 1, okay? If you element wise, you still get 2, okay? So that means top multiply top, bottom multiply bottom. Then you concatenate 3 things. You concatenate what we dot, you concatenate original U, original H. Okay? For those who would like to read papers, this is the notation, right? H1, comma U1, comma H1 element wise U1, right? This is like the, actually it should be semicolon. Yep. That would be the perfect notations here. Then what do? You take this guy, this whole thing, dot with some W. And this W is called, let's say W similarity, whatever, right? So you take this one, dot with this guy. You will get some one number, right? 1 by 6, 6 by 1, and 1 by 6, you will get one number, right? And this number is called S11. That means the similarity between H1 and E1. Okay? This is what we call S11. You need to do this for all pairs. All pairs. So finally, your big S will be T times J, in which this is T and this is J, right? So you have, this matrix will be so big, okay? It's T times J. So that's why, that means you have to do you have to do S11, S12, S12, S14, and then S21. You understand? And then for all the pair, you get T times J. Okay? This is just the beginning. This S is called similarity similarity index. Okay, between the questions and the passage. Now the fun begins. This is a context to query. So first I have the questions and the answer, not answer, passage. And let me introduce some notation that this paper used. U1 is the same as big U colon 1, okay? Okay, I don't know why the paper introduced very difficult, but they do like this, okay? Then let's say we already have the number, okay? S11 is 5. Let's say we already know S12 is 1, S13 is 15, and S14 is 5. We already know, all right? We already know. Then what do we do? This is the definition of query, context to query attention. You take this number, we call this S1 column. We softmax it, we get this number, right? And softmax just normalize to 0 to 1. We dot it with this U, right? And we'll get this U1. This represents how close how each of them is related to H1. So let me explain this this part a little bit. This part a little bit. Okay, this part is nothing but 0.2 multiply this guy plus 0.1 multiply this guy plus 0.5 multiply this guy plus 0.2 multiply this guy. You get, okay? Yep, this is the idea. This is what this equation means for those who understand. So basically, what we are trying to say is that I want to know for this passage how close this which part of the question is important for this guy, right? And it can be Chucky, right? Chucky and Chucky is very important together, right? That's why Chucky may got 0.5. That means I want this embedding more. Okay, so this is a context to query attention. Definitely, you need to do all. You need to do for all. So if you do for all H, you have six of them, right? This guy mean this guy is the average, is the weighted of all U, right? That is important to Chucky, right? And this guy is the weighted of U that is important for WAS, right? This guy is the weighted for bond at Hong Kong, right? So each of them has each of the U, right? And we call this U tilde. Why we call this U tilde? Because they are actually U, but they are perturbed U, right? They are the U change based on the passage. This is called context query attention. A little bit difficult, but I hope my picture make you understand. Okay. Now, this is a query to context. So let's say I have this attention, blah, 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 and this is just some numbers, example, all right? I did not put all the numbers because if I put all the numbers, it would be very messy. And again, H1 is the same as H colon 1, big H. And in query to context attention, first I need to draw this similarity matrix. So I have Chucky is born in Hong Kong, where is Chucky born? And I have all the numbers, right? That I computed earlier. But because I want to do query to context, I need to maximize the column, right? Which for each of the column, which one has the highest number? So I do max column operation. I got 15, 5, 15, 5, 20, 20, right? So how do I do this, right? So in the first row, the biggest number is this one. The highest column is this one. The second one is the highest column, highest column, highest column, highest column, and highest, right? So that is what maximum column does. So what does maximum column give you? Maximum column gives you the attention, right? That you want to pay the most, right? To the context, right? Then definitely you want to softmax this, and you get a series of 0 to 1, and then finally you dot with some h, all right? And so basically this one again the same, 0.03, 03, multiply this plus 0.01 plus 0.05 plus 0.01 plus 0.45 plus 0.45. Okay, same. And then you call this, actually I'm not sure what they call, but they call this probably H tutor. Yeah, H tutor. But wait, when you do this, you only get one guy, right? You get only one guy. So you just duplicate this 6 times. You will get a H prime. So duplicate this 10 times. It's a little bit weird in this step, like why do you copy 10 times? But because I guess when you maximize column, you already know the maximum attention you need to pay to which context already. So you just multiply them, 6 of them, right? Because it's always the same. So yep, those are the 2 attention they do. And if you understand both of them, you already understand by that, right? That is a bi-direction. So based on these 2 things, after they do the experiment, they found that when they do the ablation study, the context to query is the most important because it results into the highest loss in effort. And then this comes to the punchline. Chucky, you spent like 15 minutes teaching me something, but actually no one used, okay? But again, I have to teach you because who knows, right? This technique is useful for your fundamental, right? To tweak your model in the future. But anyway, nowadays, no one uses that anymore. The easy way is just concat the question, add a separator, and concat the passage, and add 2 linear layers, right? You will get the hidden state, right? And then send this hidden state to these 2 linear layers. So when you send your question and the reference, you will get a final hidden state, right? You just send this hidden state to these 2 layers and then predict the start and end. Yes. And I'm sorry, by that. I spent 15 minutes to teach that one. I can spend only 1 minute to teach this one. That is, after this student, this guy already beat, by that is 70.3, 67.7. But if you use bird large, it's already 90, right? Using this simple technique. So yeah, I spent only 1 minute on this one. But reading comprehension is still a lot of problem. If you do some adversarial examples, that means maybe you add some fake information like this. It answers some fake information instead of the real information. Yep. So it does not work very well with fake examples. And it cannot generalize. If I train the squad, if you train the squad on squad, definitely it will be high. But when you transfer learning to other similar data sets, their performance go very bad. So cannot transfer very well. By the way, all these data set, same task, passage, question, answer, yeah, same. So they cannot transfer very well. How do we transfer very well? Instruction tuning. Instruction tuning fix everything. If you do some human-made tests, it can also not pass, all right? But I will not talk too much about this slide. Okay, yep, that's it for the reading comprehension. Hopefully you guys understand this. Basically, the punchline is BERT already fixed this problem. You don't need to work on this problem. If you see this kind of problem, just use BERT, all right? Yeah, any questions? I can wait for 1 or 2 minutes. Otherwise, let's say goodbye. Okay, thank you very much and see you Wednesday. Bye-bye. Bye-bye.